For the first problem, we're going to compute the limit as x approaches 4 of x squared minus 16x plus 48 all over x minus 4. So we can't just let x be equal to 4 because then we would have a 0 in the denominator and we can't divide by 0. So let's go ahead and try to factor the numerator. So we have x squared minus 16x plus 48. Now we need two numbers which multiply together to give 48 and add together to give minus 16. So minus 12 and minus 4 are candidates. So let's factor the numerator as x minus 12 and x minus 4 all over x minus 4. Now that allows us to cancel the x minus 4 in the numerator with the x minus 4 in the denominator. So we now have the limit as x approaches 4 of x minus 12. So now we can just go ahead and let x equal 4. And the answer to the problem is minus 8. So the limit as x approaches 4 of this function is equal to minus 8. Let's move on to another problem. We're going to figure out what the limit is as x approaches 0 of 2 times cosine of x divided by x plus 10. So notice here that our function is defined when x is equal to 0. This is our function here. So we can just go ahead and let x equal 0. Now, cosine of 0 is equal to 1, as this is kind of representative of what the graph of cosine looks like. So we have negative 1 here, and we have right here we have 1. So this is x equals 0. So when x is equal to 0, y is equal to 1. So we just have 2 over 10, which is equal to 1 over 5. So the limit as x approaches 0 of 2 times cosine of x divided by x plus 10 is equal to 1 over 5. And that's the final answer to this problem. Let's move on to a more difficult problem. So we have the limit as x approaches 0 of x plus 4 squared minus 16 divided by x. So again, we just can't let x equal 0 because then we would be dividing by 0. So let's go ahead and try to multiply out the numerator to see if we can simplify this expression. So we have x times x, which is just x squared. Then we have x times 4, which is 4x. 4 times x again, which is just 4x. 4 times 4, which is 16. Minus 16 all over x. So positive 16 minus 16 gives us 0. So 16 minus 16 gives us 0. And 4x plus 4x gives us 8. Now, we can factor an x out in the numerator. And now these two x's cancel with each other. Now we can just let x equal 0, as our function is defined at 0 now, and we just get 8. So the limit as x approaches 0 of x plus 4 squared minus 16 divided by x is equal to 8. For our fourth problem, let's try to solve the limit as x approaches 0 of the square root of x squared plus 25 minus 5 divided by x squared. So we can't just let x equal 0 because then our function is undefined as before. So let's try to rationalise the numerator. So we're going to multiply by the square root of x squared plus 25 plus 5 divided by the exact same thing. And we can do this because we're just multiplying the numerator and the denominator by the same thing. So essentially this expression is still the same. So we have the square root of x squared plus 25 multiplied by the square root of x squared plus 25. The square root of x squared plus 25 multiplied by 5. Minus 5 times the square root of x squared plus 25. Minus 5 times positive 5, so we just have minus 25 here. And I'm just going to rewrite the denominator as x squared multiplied by the square root of x squared plus 25 plus 5. The reason that I've wrote it in this form is that it will be easier to cancel the x, or it will just make it clearer to see, because essentially that's what we want to cancel. So the square root of x squared plus 25 times the square root of x squared plus 25 is just x squared plus 25 to the first power, as 1/2 plus 1/2 is equal to 1. And 5 times the square root of x squared plus 25 minus 5 times the square root of x squared plus 25 is equal to 0. So we're just left with minus 25 divided by x squared times the square root of x squared plus 25 plus 5. So we have a positive 25 here and a negative 25 here. That just equals 0. Then we're just left with an x squared in the numerator. Now, we can cancel these two x squareds here. And we're left with 1 over the square root of x squared plus 25 plus 5. Now, we can go ahead and just let x equal 0, as our function is defined when x is equal to 0. So we have 1 over the square root of 25 plus 5, which is just equal to 1 over 5 plus 5, which is just 1 over 10. So the limit as x approaches 0 of the square root of x squared plus 25 minus 5 over x squared is equal to 1 over 10. So for the final problem, let's figure out what the limit is as x approaches negative 6 of 1 over 6 plus 1 over x, all divided by x plus 6. So we're just going to go ahead and cross multiply these two fractions in the numerator so that we can simplify. So we're going to have the limit as x approaches negative 6 of, so we're going to have x multiplied by 1, which is just x, plus 6 multiplied by 1, which is just 6, and 6 multiplied by x, which is just 6x, all divided by x plus 6. So in order to simplify the numerator, we're going to multiply here by 6x, but we have to do the same to the denominator. So we're going to multiply that too by 6x. Now, this 6x cancels with this one here, so we can rewrite this as the limit is x approaches negative 6 of x plus 6 all over x plus 6 multiplied by 6x, and these two cancel here, so we're left with the limit is x approaches minus 6 over 1 over 6x. Now, this function is defined when x is equal to minus 6, so let's just go ahead and let x equal minus 6. So we have 1 over 6 multiplied by minus 6, which is just 1 over minus 36. So the limit is x approaches negative 6 of 1 over 6 plus 1 over x, all divided by x plus 6, is equal to 1 over minus 36. If you enjoyed the video, make sure to like, subscribe, and if you have any suggestions, leave a comment below.